Now, the actual fundamental theorem of algebra is a little bit more math wordy than these 3 bullet points I'm giving you. And one might argue that, like, my first bullet point there is actually a corollary to the theorem, like something that comes from the fact that the theorem is true. But for our purposes, this is basically what we need to know about the fundamental theorem of algebra. I think you spent a little bit more time in pre-calculus looking at the mathy definition. But wouldn't you argue this very first bullet point we've said since day 1 of polynomials? The total number of zeros is equal to the degree. Okay, that's basically what the fundamental theorem of algebra says. So I want you, when you're like taking your quiz on Thursday, when you're doing your test next week, Tuesday and Wednesday, I want you to make sure you hold yourself accountable to all zeros. If I say find all the zeros and the degree is 5, you have 5 zeros listed. If you only list 3 zeros, you're missing 2 answers, and you'll be docked for that. What are some other words that we have said are interchangeable with the word, oops, sorry, didn't mean to move that. Interchangeable with the word zeros? Solutions, excellent, thank you. So we could also say the total number of solutions is equal to the degree. Anybody remember any others? X-intercepts, which I have down here, I'm not going to say the total number of x-intercepts equals the degree, because what if some of your solutions or zeros are imaginary, right? They won't show up as x-intercepts. Does anybody remember that fourth word?
What does it start with?
We used it when we talked about synthetic guess and check. We needed the rational blank theorem, root. Okay. You know, think about roots of trees, right? They're the parts underground holding the tree in place. And think about how we use the roots, the zeros, to build our factors to multiply to get our polynomials in standard form. So if you think about it like the factors and the zeros are at the bottom of that, that kind of makes sense that we would call them roots. So I'm going to say the total number of zeros, solutions, or roots is equal to the degree. That includes all your real and or imaginary solutions if any exist, but only the real solutions will show up as x-intercepts on your graph. And also remember, gosh, was it Thursday or Friday when we talked about multiplicity? I can't remember, but remember, if you have an even multiplicity, you'll have to remember a little bit more about the x-intercepts. What happens when you have even multiplicity for a zero?
Doesn't it bounce?
It bounces on the axis. Okay, so it has a different look on the graph. That's important. You might see that on your concept check when you get back today. Okay, we're going to start with this example. We're going to find all the zeros of the polynomial. So this is a nice one to have in your notes just so you can kind of see the full solution. Okay, so I would go ahead and jot down this polynomial. F of x equals x to the 4th minus 3x cubed plus 6x squared minus 2x minus 12. Now, on your quiz on Thursday, on your test next week, you're going to have some sections that just say, find all the zeros. And you have to think about, what are my options for finding zeros of polynomials? So our first method for finding zeros of polynomials was back when we did that pink sheet as notes, factoring, right? So I will always choose factoring if possible, because I think that's faster. I would just find my zeros. I know how to factor. I can get them right away without guessing and checking. Okay. So do we know how to factor polynomials with 5 terms? No, that's not on our factor sheet. So right now, factoring is not an option for me on this particular problem. So when things can't be factored, then we're going to use our second method, which is the synthetic guessing and checking, right? What are you looking for when you do your synthetic guess and check? A remainder of zero. Smiley face in that remainder spot, right? Because that means it goes in nicely and it is a factor of the polynomial. Okay, so it is a zero of our polynomial function. And that also means you have to know your rational root theorem. So we're going to start with rational root theorem. Can you guys go ahead and you can talk to your group members as well. Make a list of possible zeros for me. you refresh our memory from last
Isn't this
week,
like
what's that
Theorem
list of
here?
possible rational zeros?
Oh, it's the first one.
You can look back in your notes to rational root theorem if you need to, if you're having trouble remembering. And if your group has a list, go ahead and start checking some.
Is it 3, 4, 6, 12? Is that it though? That's it?
You have a list of all the possible zeros. So just know, like on the quiz or the test, I need your final list to be in the form plus or minus 2 or here.
It has to be
So
plus
like
or minus.
A, C, or P,
That's what she said.
but they should have plus or minus. And then like, you know, obviously those
Oddly
are
wrong.
Q, so then.
Oddly it's right. Let's take this one.
But just plus or minus. Did you hear me about that?
So we have 1, negative 3.
Great list of zeros. You have a list of possible zeros.
I can say 1 is 0.
Okay, so don't forget the plus or minus.
So I'm gonna
Point
try
for that
one.
if you don't have it. So one thing is that we understand the rational root theorem, we know where that letter is. Oh, it's a
I don't think you would just hit me on the head.
And so you have your list. Now, Lilith, you'll have to remember to put that plus or minus on there. Because then you're mixing up half of the possible zeros. Thank you. And what's your list of possible zeros looking like? Good, you guys all agree with that? Avery, you better have a plus or minus on that list or you're gonna lose half a point. Or sorry, not half a point. Don't try it, zero. Do you have a plus or minus at the front of your list? So I'll try. So you're calling these Q's? You switch your letters again. You got a plus or minus at the front of your list? Minus 1 without it. You're missing half the possible zeros. I simplify it. They're just like 1, 2, 3, 4. Okay, what else should we try? Negative 2? Yeah. Negative 2.
See, those 2 ones don't work.
Okay, I'm going to do a little bit of crowdsourcing here. Did any groups find any zeros that work? Sierra, which one you guys got? Negative 1? Okay, hang on, Logan. Okay, so I'm going to put negative 1 in. Run through my synthetic. Oh, yeah, that works. Okay, now you might at that point, so I'm just going to kind of like walk you through what I'm thinking about. You might at that point stop and see if you could factor the new polynomial, right? So like this was x to the 4th. This is x cubed, x squared, x and a number. And do you know how to factor things that have 4 terms?
Grouping.
Factor by grouping. So you might think like, what if I group these two together? It would be x cubed minus 4x squared. So I could take out an x squared and I'm left with x minus 4. What if if I group these two together, 10x minus 12, I could take out a 2, but that's 5x minus 6, and Grace is saying that's not going to match, so you can't factor. So then we do want to check again and just kind of build off of synthetic. So remember, that's an option. You can stop and see if you can factor, but if you can't factor, then you keep checking other zeros. I will always give you like enough possible zeros like that work so that you could keep going and be able to get it down to a quadratic. Okay. So Logan, you guys found one that works. What's another one that works? 2. So I'm going to put a 2 out here. 1, 2, -2, -4, 6. Oh, yep, sure enough, it works. Okay, so in my list of zeros, I have -1, 2. And then I would stop and do that whole piece again. So like, this was x to the 4th, this is x cubed, so this is now x squared, x in a number. And my recommendation to you is, anytime you get it to a quadratic, rewrite it as a polynomial. So x squared minus 2x plus 6, and I'm going to set it equal to 0. Now you might check that one. Does it factor? Do you have factors of 6 that add to make -2? No. And so you might be like, well, then I should keep going with synthetic guess and check. But if it did factor, then if it had more solutions that were available in synthetic guess and check, then it would factor. They would be rational, and it could factor. Since this doesn't factor, that means none of the other zeros on that list work. So what do you do with quadratics that you can't factor? Quadratic formula.
I was going to say
You were going to say what?
squirrel.
No! Oh my gosh. X equals -b plus or minus the square root of b squared minus 4ac all over 2a.
That's gonna be stuck in my head.
I'm fine with that. I'm totally fine with that. Do not mind at all.
This prompt has no regrets.
No regrets.
Why?
So that's going to be 4 minus 24. Which now we can see why it didn't factor, right? 4 minus 24, my discriminant is negative, so I'm going to have 2 imaginary solutions, which they're not on that list. So it's 2 plus or minus the square root of -20 all over 2. This is a good review for us back from chapter 3. I'm going to pull this up to the top here. When you get to this part where you're like wanting to simplify, remember you always have to simplify this radical. So obviously we can take out an I. Can you simplify the square root of 20? 4 times 5, so the square root of 4 is 2. So it's going to be 2 plus or minus 2i square root 5 all over 2, which is just 1 plus or minus I square root 5. But you can't divide everything by 2. You can't make this 1 plus or minus the square root of 20. You can't make this 1 plus or minus the square root of -10. That's not a thing. So you have to simplify that radical, and then all 3 numbers have to simplify. So now I could add those to my list. So I have 1 plus or minus I square root 5. Now, how many zeros do I have? 4. 2 imaginary, -1 and 2. How many zeros am I supposed to have, according to the fundamental theorem of algebra? 4, because it was an x to the 4. So have I found all the solutions? Yeah, I could stop looking. How many of those zeros will show up on my graph? 2, only the real ones. Okay. You guys got any questions for me? So we had 2 plus or minus the square root of -20, which we said we could take out an I, and then we simplified the square root of 20 was square root of 4 times square root of 5, so that's where I got 2i square root of 5. And then you're allowed to reduce like divide, if they all divide by the same factor. So all of them divided by 2. So this one's really 1, 1, 1. And that's where we got 1 plus or minus. If it was like 2 plus or minus 3i squared root 5 over 2, I couldn't just do the 2's. I'd have to do the 3. So then I would just leave it alone. In that case,
For quadratic, could it be x equals negative b plus or minus the square root of b squared minus 4ac?
yeah, that is a quadratic formula.
No.
I'm sorry, what are you asking me?
If you can do negative.
The opposite of b? Negative b? Yeah. Positive 2. B is negative 2. So negative b plus or minus doesn't mean that b is negative. It means it's change sign.
Okay, I was just asking you.
So I'm looking up here in this middle term, this is negative 2x, so b is negative 2. Therefore, I should have started with a positive 2. It would not be correct for you to have a negative 2 out here.
Because if you were doing negative b, then you put in parentheses negative.
Yeah, I just changed the sign. When I sing it, I say negative b, but when we learned it, we said the opposite of b. So then we just changed the sign to b. All right, good questions. Anything else you guys are wanting to know? Okay, next up, the complex conjugates theorem. Yep. Complex conjugates theorem. Better be writing this down, TJ. Let's go, let's go. I want to have some time at the end to go over my favorite mistakes from your concept check. Okay, complex conjugates theorem. That sounds a lot like irrational conjugates theorem, right? And the irrational conjugates theorem from last week said, like, if 1 plus the square root of 7 was a 0, then 1 minus the square root of 7 was a 0, right? And so the complex conjugates theorem just says if you have one imaginary 0, then the pair is also a 0. So if a plus bi is a 0, then a minus bi is also a 0. And just like the irrationals, some of them are easier and some of them are a little bit longer. Okay, so let's start with an easy one. Let's write the polynomial with zeros, negative 1 and 4i. How many zeros do they give me? 2. How many do I know there actually are?
1.
There are really 3, because if 4i is a 0, what else is a 0? Negative 4i is a 0. So this would be one I would call like one of our easier ones. When I write those out as factors, for negative 1, that's going to look like x plus 1. For 4i, I'll write x minus 4i. And for the negative 4i, that'll look like x plus 4i. Remember, they always look like the opposites when we put them back into their factors. Which 2 would you multiply together first? The ones with i's in them, right? Because what should happen when you multiply these imaginary factors together? No more i's. You should get like some kind of trinomial, but it should have no more i's in it. Okay? So let's boil it out. X times x is x squared. X times 4i, 4ix. Negative 4i times x, negative 4x. Don't they cancel? Okay. And then what about negative 4i times positive 4i? Negative 16i squared. I squared is
1.
negative 1, so that's negative 16 times negative 1, which is plus 16. Okay, and doesn't that make sense? If your factor was x squared plus 16 and you set it equal to 0, you'd subtract 16 and then square root and get plus or minus 4i.
Because if they're the same, but they're
Opposite signs?
opposites, then wouldn't you just
And then we still have to multiply that x minus 1. Oh, plus 1, you're right. Thank you, Katie. Plus 1. So then my final answer on this one's going to be x cubed plus x squared plus 16x plus 16. Now, of course, we can expect there are some less nice ones when you actually have like an a value with your I, right? So we'll just kind of run through this one real fast. We'll do our, should we do our mathematician shortcut or trinomial by trinomial? Shortcut. Okay. So if we have the zeros of 0 and 2 minus 3i, we can write out the factors. We're going to have x for the 0. And then we're going to have x minus the quantity, 2 minus 3i. And what's our other 0? 2 plus 3i, so x minus the quantity, 2 plus 3i. Okay, so my next one I'm going to set up my shortcut. Get rid of these parentheses. So that's going to be x minus 2 plus 3i and x minus 2 minus 3i. They should at this moment have the first two terms look exactly alike. Don't they both look like x minus 2? Okay, so regroup x minus 2, x minus 2. And then distribute x minus 2's. So treat it like a binomial now. So we're going to take x minus 2 times x minus 2. And so you can write that as x minus 2 squared. I'm just going to write it out because I need to FOIL it anyway. What happens with the outside and the inside terms?
Cancel.
They're going to cancel out. One of them is going to be times negative 3i. The other one's going to be times positive 3i. So they're going to cancel each other out. So that's kind of like Lexi's shortcut question in our homework problem. And so the only other one that I really have to be concerned with is the positive 3i times negative 3i. Negative 9i squared. Oh yeah, you gotta remember, I times I is I squared. And then this is gonna give me x squared minus 4x plus 4. And then what happens to negative 9i squared? It's really negative 9 times negative 1, so yeah, that's a plus 9. So then I get x squared minus 4x plus 13. I gotta do all that simplifying, all that adding, multiplying together. And then I can multiply by any remaining factors. I'm gonna have f of x equals x cubed minus 4x squared plus 13x. So if you like that shortcut method, you can use that. It works every time with irrational and imaginary solutions.